Hello everyone, how are you? Now, today I am going to tell you about the second part of unit and measurement, that is dimensional analysis. Before starting this topic, one thing I want to share with you, that for a physical quantity, always three things are associated. What are those three things? The first thing, every physical quantity must possess some symbol. Number two, every physical quantity sub possesses a formula. And number three, every physical quantity must possess some unit, but this is not necessary. This one is not necessary because there are so many physical quantities which are unitless. So we cannot say this is compulsory that with every physical quantity unit is required. Now, in the same way, the fourth parameter of physical quantity is named dimension. Like symbol, like formula, like unit, the fourth one is dimension. Now the question is, what is dimension? Look here. Dimensions of a physical quantity are the power to which units of a base quantities are raised to represent a derived unit of that quantity. What this means? For example, suppose that you want to calculate dimension of a physical quantity like volume. You all know that volume is length into breadth into height. For length, capital L. For breadth, capital L. For height, capital L. Because all the measurement of length, either breadth or height, will be in meter only. That is why I am writing here L, 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 L. So it will come L cube. What this indicates? This indicates that volume is a physical quantity, or the power is 3, to which units of a base quantity is a base quantity means fundamental quantity, that is length, or represent a derived unit of that quantity. Quantity is volume, unit of volume is meter cube. So with the help of dimension we can understand the unit of a particular physical quantity. This is the example. Now one thing in your mind, that why I am writing L only here, why not other symbols? For that, because there are 7 fundamental quantities, and of all 7 fundamental quantities their dimensions are known. What are those dimensions? The fundamental quantities, already you know: mass, length, time, temperature, current, amount of substance, and luminous intensity. Mass starts with m, so I am writing here m. Length with L, time with T, temperature unit is Kelvin, current unit is ampere, amount of substance unit is mole, current intensity, luminous intensity symbol is candela. Now, when you put in this square sign all these things, then it will come dimension. Means one important thing, when you are going to write dimension, you must use this particular symbol which is known as square. It is a mathematical denotation. That is why this is not dimension, because you are writing this particular symbols in square. If you will not put a square, it will be wrong. So always remember to put the square sign along with this symbols M, L, T, K, A, mole, candela. Now if you know all these dimensions, you can calculate dimension of derived physical quantity, because you have already studied what are derived physical quantity. For example, you want to calculate dimension of velocity, you want to calculate dimension of acceleration, you want to calculate dimension of force, you want to calculate dimension of kinetic energy. Before calculating these physical quantities dimension, some things you should know about the dimension. The first thing is what? Dimension of all the numeric values. Numeric values means if it is 1, it is 2, or in the form of fraction, or in the form of decimal, either pi, something like this. Its dimension is always 1. Remember that. Number 2. Dimension of unitless physical, because there are so many unitless physical quantities like refractive index, no unit. So if such type of physical quantities are there, then their dimension is also 1. Means unitless physical quantities dimension is always 1. One thing I have told you here also, that when you write the dimension, put the square sign. The first property, second property, third property. Fourth property is what? Sometimes what happens? Two different physical quantities possess same dimension. It may be because like work, energy, both are different physical quantities, but both units are same. So because units are same, so their dimensional formula must be same. So there is a possibility like this, that two different or three different physical quantities possess same dimension. But one important, a physical quantity cannot possess more than one dimension. This is also important. Like work. Work is having only one dimension, not two dimensions. So these are some properties which we should know while writing the dimension. One more thing. Dimension of all the trigonometric ratios like sin theta, cos theta, tan theta, sec theta, cosec theta, etc., etc. All dimensions are always 1. Now the question is, how we will calculate dimension? During the calculation of dimension, we should know the formula of that physical quantity. If we don't know the formula, we cannot calculate. Like velocity. Velocity is displacement upon time. All of you know. Displacement measures in the form of length. So the dimension of length is L. So we write here L, we write here T. Because you are writing dimension, put this side. Now the formula will be LT minus 1. Now you can see no mass factor is here. So if you are writing mass also, put power 0. Means velocity dimension, there is no role of mass. Only one dimension of length and minus one dimension of time is required to tell the dimension of velocity. Acceleration is change in velocity upon time. Velocity dimension already you have calculated here. So directly you can write LT minus 1. Time is T. On combining, you will get LT minus 2. For force, formula is mass, acceleration. Mass dimension is M. Acceleration dimension is LT minus 2. On combining, you will get MLT minus 2. Kinetic energy is half mv square. Half numeric value. So it will be 1. Mass M. Velocity LT minus 1 whole square. Now it will come M L square T power minus 2. In this way, you can calculate dimensions of different physical quantity. But for that, the common thing is what? You should know the formula. If you don't know the formula, you cannot calculate the dimension of physical quantities. So my dear students, in this way, you can practice other physical quantities, how to calculate their dimension. Thank you.